right, this is an instructional video on lesson 6. Our lesson 6 question is, how can we explain the movement of air in a hail cloud? So just to refresh your memory, lesson 5, we learned that the sunlight heats up the ground and the ground warms up the air right above it through conduction. When that air warms up, the particles start moving faster, they spread out, and they become less dense, and they rise. That air rises. And then once it goes higher up into the atmosphere where it's cooler, the particles cool down. So they lose energy, they slow down, they condense, they become closer together, they become more dense, and that air will sink back down to the ground. So how can we use that information and what we learned about air to explain movement of air in a hail cloud? So now we're going to talk about what happens inside of the clouds, and specifically a hail cloud. All right, so you're going to take a moment and you'll pause this video and you will write down these questions. So copy these questions down, and then you have on the next page another slide, 2 more questions to copy down. So take a moment, pause the video, copy those questions down. You'll see them in the slide deck. When you open up the slide deck, you saw that there are these questions already in there. So take a moment and copy those down. Okay, now that you've copied the questions down into your notebook, we're going to answer the questions that you did. Number 1 says, do larger parcels of air outside over the course of a day also end up doing what the balloon did in our classroom? So you guys whiteboarded this last week on Friday. You whiteboarded what happened to air when it was heated. You have a class consensus model of what happens to the particles of the air when they are heated, what happens to the particles of the air when they are higher up in the atmosphere, and what they end up doing once they are cooled down. So go ahead and answer number 1 and make sure you give an explanation to it as well. So answer the why. Number 2, if you could observe the motion of the air in clouds on a day when it hails, what do you predict you might see happening? So think about how clouds might be moving, or motion of air in the clouds on a day when it hails. So it's hailing and you look up and you see this cloud. Imagine what the air is doing on the inside of that cloud. Go ahead and make a prediction for number 2. Okay, here's a cloud. So this is slide B. This is number 3 in your notebook. Take a moment. You can pause the video. What do you notice about this cloud? I want you to describe what you see, everything you see about this cloud. Shape, texture, color, all of it. So take a moment. Answer number 3. Okay, number 4. This is slide C. So you've got the cloud that you observed and wrote your observations down. You have that cloud on the left. It's called a cumulonimbus hail cloud. So this is a type of cloud where hail is formed. It's called cumulonimbus, and you described it in number 3. How does that cloud compare to the other clouds that you see in this picture? So you can take a moment, pause this video. You have different elevations. So we have 0 feet. So we've got a couple of clouds that can form slightly above sea level. And then 5,000 feet up, we've got some clouds. I think those are birds. Then 10,000 feet to 15,000 feet, so mid part of the atmosphere or the troposphere, we have these kinds of clouds that form. And then at 20,000 to 25,000 feet in our troposphere, we have these kinds of clouds, but notice how tall our cumulonimbus cloud is. So that's one way that you can compare this cloud to some of these other clouds. It's definitely the size, but also the shape and the texture, the color. Go ahead and make some comparisons between the cumulonimbus cloud and these other clouds. Up here is a plane, and this is not a cloud, this is a contrail. So you can ignore that. Okay, So number 5, this is slide D, what do we know about the temperature of the air at different heights of a cloud? So going from 0 feet all the way up to our 25,000 feet, what happens to the temperature of the air? Remember that we learned this in a previous lesson. So number 6, how might the temperature difference, so what happens up in the atmosphere with temperature, how might that be related to the formation of hail? So think about what we learned about air lower down to the ground and what happens to that air as it goes higher up in the atmosphere. How could that relate to the formation of our hail cloud? You'll pause that, answer those questions. Okay, now that you've answered those 6 questions, we're going to take a look at a video. It's a time-lapsed video of the formation of a hail cloud, our cumulonimbus cloud. So I will click on the video. I'm going to pause it at different points, but what I need you to do is make sure that you have this doc. So you're going to keep track of some patterns that we see in the motion of the air as this type of cloud forms. So grab the doc if it's not been passed out to you. It looks like this. So we're going to track air movement in our cloud formation at different points in the video. So grab that. Yours is going to be a black and white copy. And here's what we'll do. So as we're watching the video, we're going to use upward pointing arrows to label spots in the hail cloud where we saw air moving upward in that video. We'll put an X to label any spots in the hail cloud where we saw air that has been rising where it stops moving. So we'll put the X at the point at which it stops moving upward. And then we'll show downward pointing arrows on any spots in the hail cloud where we see air moving down. Okay, so grab that doc, and I've got mine right here. Okay, so I'll kind of go back and forth between the doc and our video. Okay, so here's our video, and we'll hit play, and I'm going to stop it. I want you to watch the cloud form, and I'm going to stop it at about 40 to 43 seconds. So remember, we're watching for places in the cloud where we see air rising up, where it stops, and where air is moving down. Okay, so we'll start with the first 40-ish seconds of the video. Okay, so remember that this is forming, it's in the process of forming a cumulonimbus cloud. So we're at the beginning stages of the cumulonimbus cloud forming. Okay, we see some air rising up over here. Stops right up there. And then it kind of comes back down. Okay, so we're at 43, 44 seconds. Okay, and that resembles the very first picture of our handout. Okay, so I'm going to click play. Got to get rid of my pen here. All right, there we go. I'm going to click play. Nope, I'm not going to click play because we've paused it. Sorry. So I'm going to click the pen and kind of draw where we saw air rising. Okay, so we kind of saw air rising up here. Okay, so we're drawing our arrow, and then we're using an X to label the spots in the hail cloud where we saw air that stopped, where it rose, but it stopped moving. So it kind of stopped moving about right here. Okay, and then we're drawing arrows pointing down to label spots in the hail cloud where we saw air moving down. Okay, so I'm going to kind of get out of the pen. I'm going to go back and see if we can see any air moving down. Okay, so we see air rising. Okay, now here I see some air going down. Here's some air going down. So you can kind of see billowing up. There it goes. Okay. All right, so we're now kind of going into the second part. So we're going to 45, 47 seconds, and we can continue on by marking where air is continuing to move. This is where it stops. We're seeing air kind of move back down. All right, so I'm going to back it up and see if it follows the pattern of the arrows that I drew on the screen. All right, rising, 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 stops, falling back down, kind of falling back down here, a little bit here. Oh, it's moving this way. So here at about, let's see where are we at? Kind of closer to the end. There. We saw our air going that way. Okay. Got to go back. Oh, what happened? Hopefully I won't get a... Oh, my little arrows went away. All right, there they are, forming. Air is rising, starting to rise. Start to see that first picture right here. So air is rising. Falling. Adding more, there it goes, rising. Okay, stops here. We can see air kind of dropping here. There's some air dropping here. Okay. More time. See it spreading? We have our clouds spreading, kind of moving this direction. Air is falling here, air is falling here. Okay, so we'll go to our handout now. And we'll go to this handout. And let's draw our arrows, okay? So I'm going to take a red colored pencil just to show those arrows. Okay, so we saw air moving up. Here's where it stopped on that picture. Okay, air is rising, stops. Air continues to rise. We're going to start to see that descent now. So we saw air rising up here. We kind of saw some of these clouds, this air in the clouds drop down. Okay, starting to move this way too. Okay, moving this way, stops here. We're starting to see this air drop here. Okay, and finally, the last 5 seconds or so, air is billowing up, stops right here, moves this way. We see some of this air dropping down there. Okay? Okay, so we can see that our air is following in the same way that our balloon did. Air rises, hits a point at which it stops, and then it drops back down. Okay, and we get kind of this rolling motion of this cloud.